Hello, and welcome to the second video of our tutorial series. Here I will show you how to create a whole measurement cell from scratch. This includes importing machines, sensors, and other objects from the library, and how to position them, and to align and link them one to another. First of all, we create a new project. After that, you open the library window by clicking on the right top button. It could take some time to load the library. To start off, we will insert a 7-axis robot to the 3D environment. This means that we will connect a 6-axis robot to a linear track. To do so, we will first search for the linear track. You can either scroll down in this list, or if you know the name, enter the name directly. We will use the KUKA KL250. To insert it, hover above the picture, click on it, and drag it to the 3D environment. Now you can insert a robot. I will use the KUKA KR16. Edit. As you can see, both objects are marked red. That's because they are still not linked one to another, and they virtually collide. To fully understand how linking in Nexos works, I will show you where you can look up the list of the links between the axes. On the left side, you can see the project window. There is a list of all objects that are included into the 3D environment. Click on the small arrow on the left to open the property list of the machine. In the model section, you will find the link list. Press on it and press Ctrl and E to expand the whole list. By hovering above the part and scrolling through the list, you will see that the different parts are marked on the 3D model. In this example, the base for the robot is not the linear track, but the connection between the robot and the track. As we want that the track is the base axis of the robot, we have to add it to the link list. To do so, click on the KUKA linear track and drag it on the KUKA robot. Now the linear track is the base of the whole robot. The two devices are now considered as one. It means you can move them around, as you may have already seen in the first video. The second way to move an object is through the position panel. Here you can directly enter the coordinates and the angle you want the object to have. Every machine's axis can also be separately moved. Just click on the link in the link list or directly on the 3D model. After that, you can either rotate it or drag it, depending on the axis. If you want to return the robot to the original position, you can do it through the Home command. Right-click on the robot or on the robot on the list and press Go Home. If you want to change the robot's home position, you can do it in the Property panel. Enter the value you want to have and you will see that this is now the default home position of your robot. The next step is to add a scanner to your robot arm. Search for the scanner you want to have in the library. I will use Leica AS1. Just drag and drop it to the 3D environment. It will automatically align with the robot's head. To this scanner you will have to add a compatible tracker. I will use one from the AT900 series. Make sure to choose a position where the scanner is in the field of view of the tracker. To try out if one of the scanner's faces is in the tracker's field of view, you can use the lock-on command. Right-click on the tracker, press lock on. After that, left-click on the scanner. Now that the scanner is connected to the robot arm, you can move the whole robot arm just by moving the scanner. To complete the measurement cell, we will now add a turning table. I will use the Fibro ER17 Square. Position the table in range of the robot arm, but also make sure that it doesn't collide with any other object when rotating. In case you are using a PLC to communicate with your turning table or other devices like a photoelectric barrier, you can use the PLC from the library. Within the project panel, in the PLC connectable tree, you can create variables of the type Boolean, string, integer, and double. Those variables can later be used to create conditional commands when reprogramming the machines. More information to this topic you will get in another video. The last step for the creation of a cell is to insert the object you want to measure. For this purpose, I will use the demo block from the library. To place the block on the turning table, we will use the alignment mode. First of all, move the block as close as possible to the position you want to have it. Now start the alignment mode. Choose the object you want to align. After that, the surfaces you want to align one to another. As you may have seen, I've used this button to change the direction of the block. In this input windows, you can enter the offset you want the planes to have one to another. Except if you are satisfied with the object position. The problem now is that the object is still not connected to the table. To attach the block to the turning table, open the turning table's linked list, right-click on the link of the table itself. Execute the command Assign Graphics and click on the block. Enter to confirm it. Now that the block is attached, the block will move with the table. With this step, you have completed your first measurement cell. If you're still not sure whether the positioning is correct, you can use the measurement mode. With this mode, you can measure distances between planes, edges, or corners. This also works for angles. I hope our video for the creation of a measurement cell was helpful. You can reread this information on our Zoho Learn platform.